This super smart physics guy Michioku. You know, the one who's a big deal in the world of science? Well, he's been talking about some wild stuff. The James Webb Space Telescope found. He mentioned that the telescope spotted 6 huge galaxies that honestly shouldn't even exist according to what we thought we knew. This is a huge deal because it could totally change how we see the universe. It's like finding out the rules of the game were wrong the whole time. These galaxies are so big and old that they're messing with our current ideas about how galaxies are born and grow. Kaku, being the cool scientist he is all about these new finds. Unlike some other scientists who are a bit stuck in their ways, he's open to the crazy stuff the telescope is showing us. He's excited to share it with everyone, which is pretty awesome. He even sounded like a kid in a candy store when he talked about it. He's really into this discovery, and that's saying something. Now Kaku is not just some random guy. He's got a reputation for thinking outside the box. I mean, he gets that. Einstein and Newton gave us a good start, but their ideas can't explain everything we're seeing out there. He knows the telescope's discoveries could turn the world of physics upside down. Some scientists are probably losing sleep over this, especially those who are super attached to the Big Bang Theory or have strong opinions about quantum mechanics. But Kaku, he's laughing it off. These galaxies are real head-scratchers. They're packed with more stars than our own Milky Way, even though they formed super early, like only a couple of 100 million years after the Big Bang. The astronomers who found them are calling them universe breakers. If these finds are true, we might have to rewrite the entire cosmic story. The problem is, the Big Bang Theory paints a picture of the early universe as a chaotic hot place. It says it took ages for things to cool down and come together, and it took millions of years for light to even pop up. So how could these giant galaxies exist so soon? Some of these galaxies are bigger and brighter than the Milky Way, which means they were making tons of new stars all the time. Unlike our galaxy, which has been a bit slow to start, we don't even know when the first galaxy actually formed. Scientists previously thought only little stars or groups of stars started. These came together to form many galaxies until dwarf galaxies popped up. After that, some small galaxies met others and just grew larger from there. So big galaxies this early, it just doesn't add up. This has scientists wondering, is the universe way older than we thought, or did galaxies grow up way faster? Those older scientists are probably having a hard time with this. Kaku gets the resistance. He says that sometimes old ideas stick around even when they're wrong, just because some important scientists say so. But a huge experiment can prove them wrong in the end. To his point, physics lies with the experimentalist. Think about it, we're still figuring out the cosmos. The Big Bang Theory came about in the 1920s from the observation of an expanding universe. It suggested the universe grew from a single point. It was difficult to grasp, and scientists have been working towards it ever since. These new finds don't exactly match what folks have believed for decades because of the Big Bang Theory. These will need to be confirmed and observed repeatedly. Remember when people assumed Earth was flat and the sun moved around us? They had scientific proof until something came, changed the image. We are experiencing a similar time right now. They wanted to prove the Big Bang, but instead found 6 galaxies that seemed impossible. You see, science is always in motion, and these challenge the theories being created. Physicists are utilizing the red shift as a tool when studying the cosmos. This phenomenon is basically how car engines sound higher in pitch when they come close and lower in pitch when they travel further from you. It's very similar, and it's how they measure. They convert those measurements into speeds and distances. If it gets mixed up, the numbers can be off. We will see what researchers find in the end, because maybe those numbers are off or someone is in denial. The universe continues to surprise us, and those ideas and questions are always going to be there to push us. These galaxies and celestial bodies challenge our understanding and expand scientific beliefs. Apparently this discovery could totally shake up how we understand the universe. It's a game share messing with ideas about how galaxies even form and grow, so yeah, we should all be paying close attention. The fact that Kaku, a super respected dude in science, is backing this up, that's a big deal. He's a Japanese American physicist who's a whiz at both old school physics and that crazy quantum stuff, and unlike some of the more stuck in their ways scientists, Kaku's been pretty open to the wild findings coming from the James Webb Telescope. He's all about new discoveries and sharing them with everyone, which is awesome. It's great seeing him speak up about something that's pretty undeniable. At this point you can practically hear the excitement in his voice when he talks about the telescope's find. It really got his attention. Now Kaku's always been one to think outside the box. He's never been afraid to question things. He gets that Einstein's and Newton's ideas were great, but they don't explain everything about the universe. According to Kaku, the discoveries from the new telescope can help give a better understanding of the scientific field. It's causing a stir, even some sleepless nights for folks on different sides of things, but Kaku just laughs it off. So, about those galaxies, the James Webb Telescope spotted 6 massive ones that go way back to the early days of the universe. Each one has more stars than our own Milky Way, even though they formed just 200 to 700 million years after the Big Bang. The astronomers who found them are calling them universe breakers, because if they're the real deal, they could flip our entire understanding of the cosmos on its head. What this suggests is that the early universe was way more active and complicated than we thought. Something doesn't quite add up anymore. The Big Bang Theory says the cosmos was a hot, messy place early on. It took ages for the first objects to form and millions of years more for them to get dense enough to make light. Complex stuff like galaxies was supposed to come much later. Some of these new galaxies are bigger than the Milky Way and are super bright, meaning they were probably cranking out hundreds of new stars every year. Our galaxy, it makes stars here and there. No one's really sure exactly when the first galaxy popped into existence. It's all a bit of a mystery. What we do know is that there were probably just single stars or small groups of stars at first that eventually got together and formed larger and larger clumps until dwarf galaxies showed up. Then those small galaxies bumped into each other and gradually grew bigger. But according to old ideas, massive organized galaxies shouldn't have existed that early. So it makes you wonder, is the universe way older than we thought, or did complicated galaxies develop way faster? This is hard for some old school scientists to swallow. Some just don't want to believe it and question errors with the date calculations. Kaku knows this, saying there are outdated ideas that refuse to die because some scientists are just too famous. He adds that these ideas were disproven when an experiment revealed their falsity. He ends by saying the crucial work in any science, especially in physics, rests within the experimentalists who keep the theorists honest. He ends by saying, we know very little about the beginning of the cosmos. Kaku's quote is to emphasize the importance of continuous experimentation and validation in the scientific process. So the Big Bang Theory came about in 1927 when people watched the universe expanding. This led to the idea that the cosmos started from a single point and has been growing ever since. Back then it was hard for people to imagine a universe with a beginning or an end. The picture of a universe that had always been around was easier to grasp. Even now, it's still tough for scientists to wrap their heads around, but we got to consider these possibilities. Again, these new findings just don't mesh with what researchers have been saying for ages about the Big Bang, but science has shown us again and again that rethinking things and being open to new ideas is key, and confirming observations is also integral. Think about it. When Einstein was a kid, everyone thought the stars and planets were stuck in place. occupying a specific spot now we know. Everything's moving. Planets orbit stars. Stars zoom around within their galaxies. And entire galaxies hurtle through the cosmos. This new dynamic view of the universe turns old beliefs on their head and shows us why it's so important to keep asking questions and adapting our ideas. Right now, scientists are being asked to accept some uncomfortable truths and to understand that theories aren't always set in stone until they've been properly tested or confirmed. The Big Bang idea came from realizing that galaxies are moving away from each other, and the faster they move, the farther away they are. This is known as Hubble's law, suggesting that the universe is expanding. Things like cosmic background radiation and the redshift of light from far-off galaxies seem to back this up. But remember, people used to think that Earth was flat and the sun went around us. They even had evidence to back it up. Until better evidence came along. We're in a similar spot right now. Scientists thought the James Webb Telescope would confirm the Big Bang but found some impossible galaxies instead. It's just a reminder that science is always changing, and we have to be open to new stuff and rethink old theories when the data tells us to. These findings challenge what we thought we knew and push us to reevaluate long-held ideas. Researchers use redshift to figure out certain things in the cosmos. Redshift is basically like the Doppler effect for light. Imagine a car coming toward you. The engine sounds higher pitched right. As it moves away, the pitch drops. Sound waves get compressed as the source moves toward you and stretched as it moves away. Same thing happens with light. When a light source moves toward us, it shifts toward the blue end of the spectrum. When it moves away, it shifts toward the red. And that's redshift. Physicists have turned these redshift values into speed and distance, helping them measure how far away and how fast things are moving in space. Tiny errors in those measurements can have big knock on the measurement. Techniques are currently under review, and it'll be interesting to see what happens for these latest cosmic revelations. We need to figure out if they're because of errors in redshift, or if some scientists are just unwilling to face the facts. It's going to take some serious analysis and a careful look at the data and the methods used. This focus on re-evaluating measurement techniques underlines that science is always changing. Thanks a bunch for watching. As always, drop your questions in the comments. If you liked the video, hit that like button, share it around, and subscribe. Thanks again, and see you next time. We want to create community of curious people who want to learn what scientists have been discovering. The study of our universe challenges scientists across the globe. Every revelation shapes our understanding of the cosmos and challenges theories such as the Big Bang. Understanding how galaxies form helps to confirm or challenge these existing theories. With cutting-edge technology, revelations reshape our understanding and push the boundaries of knowledge.